This is CJ Peaceful. This is another update regarding my 9-plate series cell. In the last video I talking about my plate gap theory. I went ahead and based on the revision to that theory, revision to the equation regarding the theory, I went back and punched in a few numbers and changed the cell configuration. And I think what I told you on the last video was that substituting voltage for amperage increased my plate gap, by actually more than twice the previous spacing. And a reason why I did that is I think with the previous plate gap at 1/16 of an inch, that cell was most efficient at about 12 amps. And I think it was proven to you in my last couple of videos where I questioned actually some of my results. I say that because I've had a lot of discussion with some individuals, and it just sort of dawned on me that maybe because my lack of including amperage into the equation, I really wasn't seeing the results that I expected to see. I think it was just a simple mistake. I think that because of not incorporating a current as part of the equation, that really threw off my results, and it can be really frustrating. I admit I was really frustrated. But like I said, I changed that. If you haven't seen my previous 2 or 3 videos, I encourage you to go back and look at those. What I've got here in front of me is the first piece of paper to your left is previous test results of the cell using a 1/16 of an inch gap, or 1/16 of an inch nylon washer between each plate. And you'll recall my first test I ran across the cell. I got 10.6 volts, and I had to start out with 10 amps, and it gave me 106 watts, which gave me a time to displace 250 milliliters of water, a minute and 7 seconds. Okay. The next test, I increased my the amount of electrolyte in my solution, which brought it up to 14 amps. My voltage dropped, of course, to 9.7, which gave me 135.8 watts. And my time actually went up by 1 second. Okay, and the next test, again, I increased my electrolyte, but apparently just a little bit, and it brought me up to 14.5 amps. And of course, the voltage decreased again by 9.65, which increased my wattage by 4 watts approximately. And my time increased by another second to displace the 250 milliliters of water. And what I eventually did is I went back and I thought, well, we're going in the wrong direction here. So there's something totally amiss here. And so I thought, well, let's decrease the amperage and see what happens, how the cell reacts. So I went back and tried some new solution. This time it was running at about 7 amps, and of course my voltage shot back up to over 10.5 volts, and actually it was 10.65 volts, which dropped my wattage consumption to 74.55 watts, and it was around a minute and 10 seconds. Now, there's probably, these numbers are probably actually, I would say they're within a margin of error of 3 to 5%. So truthfully speaking, I don't think there was much of a difference, if any, that I could have truly detected using just the homemade devices that I've created. But nevertheless, this again was based on my equation assuming that voltage, a 12 volt voltage supply should have been a part of the equation rather than a desired amperage or desired load across the cell, which now is what it's been revised to. So now we shift over to today's test results. So I'm zoom in a little bit better here. I reran it based on the revised equation, and again, it's your amperage, your desired amperage, divided by the number of plate gaps you wish to use, and divide that then by the surface area of one of your plates. And I don't mean the total surface area. So far I'm thinking it's just going to be just the single-sided. I've got some possible theories behind that as to why it's not the total surface area of a plate, but anyway. But for now, just the single-sided. And then you multiply that by 1.23 volts, which most of us know that's what's required to start the electrolytic process. Now that's using distilled water, so the voltage could be less. But I think most people would say it's around 1.25 volts. Okay, and then you get your Z, your output of Z, which of course is your plate gap. Now, taking all that into account, went ahead and reran the tests. And first test, I think my batteries are a little bit low. I'm going to recharge them later on this evening. But I got 10.2 volts across the cell at 9 amps, or 91.8 watts. It took 1 minute and 42 seconds to displace 250 milliliters. Now, you're thinking, whoa, that's a lot more. It's almost double if you look at the previous one. Yes, I agree, but things get a little bit more interesting here. Second test. Increased the electrolyte, brought it up to 13 amps. And of course my voltage dropped. That's going to happen. 10.1 volts, or a total of 131.3 watts at 1 minute and 8 seconds. Nice drop there. Okay. The third test, which is, I don't think it's going to be my final test for the day. I'm hoping to get one more test here before the video runs out. But this, I increased the solution to 16 amps. The voltage dropped to 9.67. Now that's a big difference there between the two, and from first one, second one. And I say that's probably because, excuse me, I'm almost certain that my batteries need to be charged there. But anyway, the time came out to be 56 seconds. Actually, that should be about 54 seconds. And I say that because I started the timer, and I really wish I had this on video, but I started the timer before, and I've done this before several times, before I even saw the first bubble or heard the first bubble in my 500 milliliter test jar. So I started prematurely. But anyway, that brought it to a total of 153.6 watts. Now, as you can see, my time is going in the direction in which I expect it should go. Now, how much more will this time decrease? Based on my plate gap theory, I put in this cell, I believe it was 20 amps that I wanted to hit was my target. So 20 amps, I divide that by, I've got a total number of 4 gaps. Let's try that again. Oh, I know what I forgot. I forgot the number of plates in my equation. See, I haven't even got this memorized myself yet. 20 amps. Let's try that again. 20 amps, 4 gaps, 8 square inches. Divide that by the number of plates for the series. Times that by the necessary potential, which is 1.23 volts. That's what I'm using. Gives me a plate gap of 0.15375. I have, like I said, 2/16 of an inch washers in between each plate.